Hello, my name is Ethan Schuler, and my science fair project is the 3D printed combat robot. So here's a little look at what I've been working on. So my main issue was, or my problem was, could I construct a 3D printed BattleBot with the obviously the help of a 3D printer, only like, and all the structural parts like the weapon and the chassis being 3D printed, could I create that and still compete in a competition and win? So my hypothesis was yes, I could create this because I'm very fluent and good at designing in Fusion 360, which is made by Autodesk, which is a CAD software. And also, I've experienced 3D printing strong structural parts for replacement parts for different things around the house. So I'm decent at 3D printing as well. So the BattleBot obviously has to have motors and stuff to drive it and propel it. So those, like the battery, that receiver, transmitter, that kind of stuff, isn't 3D printed. Some of the materials I used in this project were a 3D printer, of course, PLA plus filament, which I found to be the strongest filament that I've tested so far. I printed different parts here in different parts such as like the weapon and the armor, and tested them by whacking the weapon against them to see how many hits it took to destroy that part by just increasing the infill thickness. And then I also tested, see what would happen if I tested the wall thickness, which is the outer portion. So I came to the conclusion after doing many tests that 2 millimeters thick wall thickness was a good balance between weight, and also strength. And then the infill thickness doesn't matter as much because it's not the main armor part. So some other materials I used were NinjaFlex TPU, which is flexible TPU, very stretchy filament. I use this for the drive belt for the weapons. Some other parts that I used was a brushless motor, of course, to drive my weapon, and some brush drive motors, 550 RPM drive motors, to be exact. I used a 1300 milliamp hour LiPo battery to give it enough current to last a full fight, which is 3 minutes. There's some parameters some rules I had to follow, like the BattleBot had to be 3 pounds, has to be under 14 inches in all dimensions, and then the weapon and the armor has to be made out of some sort of plastic you can print on a 3D printer, common 3D printer. So some of those were PLA+, PLA, PETG, ABS. So after I got all my parts assembled and all my parts ordered and all that stuff, then I started working on the design a little bit before that, but after I got all the parts for the main part of the bot, I designed and started 3D printing, and then assembled some parts. Some issues I came across while 3D printing would be the weapon wasn't quite strong enough. If you see this gentle curve, this used to be, you see how it curves here? Well, it used to be the same on the other side, and it would snap there. So I thickened that part of the weapon up a little bit to increase the strength, and tested it further, and it seemed to be very, very strong and decent upgrade. So here's some pictures of what I've designed. I also have a CAD model here of what I designed. So I designed the wheels, which I have one here, and just printed these out of PLA. Then for extra traction, just added a rubber band. Seemed to work really well on the final bot. I printed the belt. That's the bot. Also printed the motor mounts for the drive motors. And then obviously assembled it all together. So next thing, major thing that I came across when trying to get this project working. So this was my very first BattleBot competition that I've built for. So one of the harder things I was working on was trying to work with parts, because it's an expensive project working on these. So trying to work with parts I already had, such as this, just a standard bolt. And then also these bearings are just fidget spinner bearings. So definitely something I tried to work on is using parts I have. That way I don't have to buy parts such as like belts and stuff. That's why I designed and printed my own belt. So overall, the main thing I would probably change if I ever did this project again would be working on the flat edges of my BattleBot. If I ever got flipped into this position, it would be crippling and I would definitely lose the fight because there's nothing I can do to flip myself back. So either rounding that over so I can flip on my backside and drive around, or making some flipping mechanism, something like that. Some things I was researching were the different strengths of PLA versus PLA Plus, and what I found while researching was it didn't necessarily matter that the filament was PLA or PLA Plus. PLA Plus just means they add something to it. Some PLA brands and PLA Plus brands are stronger and less strong than each other, so I just went with a trusted brand that I've dealt with a lot and bought their PLA. This is Inland PLA, which is made by Micro Center. I bought their PLA and their PLA Plus and did some test prints on the same printer, snapped them. The PLA Plus was definitely more flexible, which is what I wanted for this project. I didn't want it to be a brittle part, so that's why I went for PLA Plus over PLA. So the results on this bot was, it took me about 3 months to make this bot total with all of the different designs and iterations, because I had to test and retest some different things like the electronics. I had some issues with the power switch unclicking after a few hits, so I added this screw down switch where you just thread it in, and that's what turns on the BattleBot. So overall, this BattleBot competed in the NRC National Robotics Challenge in Marion, Ohio, and won first place undefeated. So what I took away from that was, okay, well, that's amazing, but what can I do to improve it for the next year? So I'm working on improving and reiterating different parts and designs to increase the strength, but also, since it's at 3 pounds right now, I have to cut some weight and that kind of stuff like that. So finding a good balance. This is actually the exact same bot from the competition. Nothing has changed. All I did was take this old weapon off, which is a little nicked up. I just took the old weapon off, put a new one on it. But overall, all of the scars and scratches are from the competition. So nothing has been changed there. So I didn't have any major damage, which kind of was a little sad for me, because I wanted to find things to improve on, because I didn't go against very hard competition. So overall, I think this bot was a good engineering, had a good engineering design process, a great hobby I like to do now. So just so in conclusion, the I use the engineering design process to, you know, find out I had a problem, I had my proposed solution, all of my different ideas and everything went into it, and I created the BattleBot that's right here. BattleBot demo.